What's up guys, what's up girls? In this video I'll show you how to access a process's memory and perform certain operations such as reading and writing to memory. I made a video a few years ago in which I didn't talk about this. Now I think it's a good idea to explain in more detail how it works. So I'm going to create a program on which we'll base the next video. So here, let me include stdio.h and unistd.h, and here I'm going to create a function called display value for int equal 0, e++, and I'm going to write specific value okay. Sleep for 3 seconds, and in my main function I'm just doing to call display value and here return 0. Okay, so now let's compile my game and run it. Okay, so now it's important to explain what the proc directory is. So /proc, okay, is a special file system on Unix and Linux systems. It is a pseudo file system that provides an interface to the kernel and exposes information about running processes and the system. Unlike traditional file systems, /proc exists only in kernel memory and does not occupy disk space. What's more, every process running on the system has a subdirectory in /proc named after its process it don't type here, so this is a PID. So for example, if I do pdf-s and the name of the process, we have here the PID. So if now I do ls-l/proc, the PID, and as you can see, /proc/the PID contains information on the process whose PID is this number. Okay, so in our case we are going to look at this file, okay, because if I do sudo cat/proc the PID/com, let me enter my password, and when we read this file we have the name of the process. Okay, so let me create two files called process.h and process.c, in which we'll add all the logic and how to retrieve a PID via a program name and how to read and write memory. So if I do vim and I go here, okay, so we'll therefore create a structure containing the PID and an array of characters to store the process name. So here before I'm going to write this process_h and define process underscore h and if, okay, include sys slash types dot h and include sys slash, okay, and let's create this. Let's create this structure, type def struct pid underscore t pid and char name. So let me define buff, okay, process. Okay, so now let's create our different function, but first let's explain what we are going to do. In C, the concept of objects is realized using structures and associated function. However, since C is not an object-oriented language in the strict sense, it is possible to simulate object-oriented programming by using structures for data and functions for operations on this data. And that's what we are going to do by creating the following function. Process, okay, and process create const char, so a pointer, const name, okay. So this function will allocate and initialize a new instance of the process structure. So now let's write a new function called process destroy, void process destroy, and here I have a pointer to the process structure, okay. So this function free memory allocated for process object to avoid memory leaks. Here we are going to have this function, process get pid const process and the pointer, so the pointer to the structure, and this function returns the PID of the process object. Now void process set PID process, so a pointer to the structure process PID underscore t and PID. So this function updates the process PID in the process object. So yeah, now we have a const char and pointer process get name const process and proc, okay. So this function returns the name of the process associated with the process object. It will therefore obtain the name of the process registered in the process object, okay. And here we have void process set name process, another pointer, and here we have a pointer again, and here it's to update the process name in the process object, okay. And here I'm going to write a function to read the process memory and another function to write in the memory. So let me write this function rpm const process proc unsigned long address void, so this is a buffer size t size, and here I'm going to do the same for the write process memory. Const process proc unsigned long unsigned long, okay, address const byte buffer and size t size. So yeah, so as you can see here, for example, we have a process we have the process get PID and a process set PID. Okay, so we have on set and get function, and we are going to use getters and setters. They are generally used in object-oriented programming languages such as C++ or C#, for example, but can be coded quite easily in C. And getters and setters hide the internal details of the structure's implementation and provides a control interface for accessing and modifying its fields. What's more, using getters and setters makes code easier to maintain and modify. If you need to change the way a field is accessed or modified, you only need to update the getter and setter functions, instead of updating all occurrences of direct access to that field in the code. Okay, so now let's go to our process.c file and implement the logic of our function. Okay, so let's include process.h I have the string .h and gerent.h include unistd.h. okay, and to start I'm declare the function process vm read v and process vm write v. So if you write in your terminal man process vm and read v, as you can see we have all the documentations, and I'm just going to copy and paste this. Okay, okay, so I have this, and now I'm going to write process process create const shore and pointer, and here I'm going to write process and pointer to the process structure, and to cast this I'm going to cast this malloc size of the structure. So the function uses malloc to dynamically allocate memory for a new process instance. This creates a process object at runtime whose lifetime can be managed explicitly. So we are going to now write if didn't have proc error failed to allocate memory for process. Okay, and return null. I initialize the fields, so strc strn Okay, so proc name, name size of proc name -1. So strcnp is used to copy a string from a source, so in our case name, to a destination. So this is a destination. Okay, this is a destination, sorry. And size of proc to the name -1 limits the number of characters copied to the size of the array. Now I'm going to write this size of proc name -1 equal this. Okay. So ensures that the last character in the proc to the name, so for the structure array, is a null character. Okay, and now proc to PID equal -1 indicates that the PID has not yet been defined or that the process has not been found. Okay. Now let's write dir pointer. So this is a pointer to a dir structure used to represent an open directory instance. Struct dirent and pointer name int is a pointer to dirent structure used to represent a directory entry. And here I'm going to create a buffer, and this is an array of characters used to store file paths and process names. So now let's open the /proc directory. If dir equal open dir /proc equal null, I'm going to write pure failed to open /proc. Okay, and in this case free proc and return null. Okay, and while int equal read dir is different to null of null, sorry. If is I think is digit. Oh, but you're not found. Okay, why? Man is digit. Okay. Include c type.h. Yep. So if is digit int the name. So this line ignores entries whose name does not begin with a digit. Process directory in /proc are named by their PID, which is a number. Okay, and in this case let's continue. Okay, so sn printf buffer size of buffer /proc percent C S, sorry, com, and the name. So here we build the path to the com file to the current process, okay? And now file fp equal open buffer and read. Okay, so here this line opens the com file in read mode, so I think it's not difficult now. If fp what we are going to do is if f gets buffer size of buffer and fp buffer str cspn str, okay, str cspn, okay. Here we have the buffer equal this \0. So this line deletes the new line character from the string read, and if str compare buffer name equal 0. So this line, so yeah, compare buffer, yeah. So to compare the name read with the name search for proc pad equal pad underscore t by and the name and fc close fp, and here we are going to break, okay, and fc close fp up, and here we are going to close dir, and if proc pad equal -1, oops, oh yeah, okay, sorry, free proc and proc equal null, and we return proc. Okay, now let's create a function to free the memory allocated to a process object. So I think is, oh sorry, process destroy, yeah, process destroy in P, okay, up, sorry, so void process destroy process, and the pointer to the process structure proc if proc free proc and oops free proc and proc equal null, okay, and we'll retrieve the PAD via the process object. So PAD d process get PAD const process return proc proc, yeah, PAD -1. So this lines means if proc is not null, returns yeah the PAD stored in proc PAD, so in the PAD So this is the PID of the structure process, okay? And otherwise returns -1 to indicate an error. So now we define the PID for the process object, void process set PID, process proc PID underscore t PID, and if proc PID equal PID. Okay. And we are going to do the same for the process name. Sure. Process get name. Proc none. Okay. And void process set name versus proc const sure name, and if proc and name str and cp strpy. Okay, oops. Proc name size of proc name, and here -1. So this line copies up to size of proc name, -1 characters of the name string into proc name. Okay. Oops. Okay. And proc name size of proc name -1 equal underscore 0 underscore backslash, sorry. And so this okay adds a null character to the end of proc name to ensure that the string is currently terminated. Okay. And finally we write the functions for reading from and writing to memory. Size t rpm const process proc signed long address byte buffer size t size. Okay, so if we didn't have proc, return -1, no strict UVEC local 1 strict UVEC remote 1 base equal baf local 0 dot uv underscore len equal size remote 0 dot uv underscore base equal void address. Okay, and remote 0 dot uv len equal size. and exercise t and read equal process vm read v equal proc pd local, and here 1 remote 1 0. So the fourth one indicates the number of segments in the local array, in this case a local array, yeah, and in this case a single segment, and the second one indicates the number of segments in the remote array, in this case a single segment. So if and read equal -1 pure fail to read memory using process vm read v and return and read. Okay, so we are going to do the same for the write process memory. Okay, so we are just changing this. Yeah, and that's all. But here I'm just going to replace to and write-in and do the same here and write-in. Okay, so now let's create our main function, vm main.c. Let's include stdio.h, include stdlib.h, and here include process.h. Okay, so int main void const shore, so process name equal my game, and here we are going to create a process, so process proc equal process create process name. Okay, and if not proc f print f std std error and process not founded. Okay, return 1 in this case, and here printf pad %d name %s and process get pad proc and process get name proc. Okay, return 0 gcc -o, and I don't know what name I want. Okay. Okay, so I have this, and here we have the process memory, and yeah, const. Oh, okay, I just copy paste without Okay, and right in, return it right in, and let's why oh, okay, we have to S here, so no, I think it's good. Nice. V1, good. And if I do byte-off -s my game, so yep, good. So that's fine for today, but in the next video we'll look at how pattern matching works and how to implement it. Thank you. Bye bye.